In the late 1980s, a sea that once fed empires was overwhelmed by an invisible invader. 900 million tons of comb jellies, wiping out decades of fishing tradition almost overnight. It was not just a jellyfish bloom, it was a collapse that left 20 species missing and entire coastal economies shattered. But was this devastation inevitable, or did the cracks run deeper than anyone admitted? To understand the aftermath, we have to start with the wealth and the warning signs hidden in plain sight. For centuries, the Black Sea was a living larder for the communities that lined its coast. In the early morning, fleets of wooden boats set out from harbors in Sinop, Constanta, Varna, and Batumi, their crews confident that the sea would provide. Anchovy schools, so dense they turned the water silver, stretched for miles. Nets returned heavy, not just with anchovy, but with bluefish, mackerel, sturgeon, and sprat, 26 commercial fish species in all. Each catch supported bustling markets, smokehouses, and the livelihoods of entire towns. In Turkey, generations of families worked side by side, passing down fishing knowledge as if it were a family heirloom. In Romania and Bulgaria, fishmongers and shipwrights formed the backbone of coastal economies. Dolphins followed the fleets, drawn by the abundance. Their presence was so common that old-timers recalled them as both competitors and companions, a sign that the sea was healthy. In the Soviet Union, state records from Odessa and Sevastopol tracked catches that filled refrigerated trains bound for Moscow and beyond. The Black Sea's bounty-fed cities fueled export industries and formed the heart of local culture. This was a sea of shared prosperity. Romanian and Bulgarian fishing cooperatives, Turkish family firms, Soviet state fleets, all relied on the same cycles of migration and spawning, the same natural rhythms. Annual catch ledgers from the 1970s and early 1980s show steady harvests, with hundreds of thousands employed across 6 nations. The diversity of the fishery was its strength. If anchovy faltered, bluefish or turbot might fill the gap. But beneath this abundance, subtle changes began to stir. As the largest predators dwindled, the balance shifted. Still, for most who worked the water, the Black Sea seemed inexhaustible, a gift that would last forever. By the late 1970s, the surface of the Black Sea was changing in ways few noticed from the shore. Fertilizer runoff from the Danube and Dniester rivers surged as agriculture intensified across Eastern Europe. Year after year, more nitrogen and phosphorus poured into the sea, fueling thick blooms of phytoplankton. The water turned greener, cloudier, and oxygen levels in the lower layers began to drop. Coastal scientists recorded these trends with growing concern. Measurements from the Danube Delta showed nutrient loads doubling between 1970 and 1985. Where once the sea had cycled nutrients naturally, now it was absorbing the waste of entire economies. Port authorities in Odessa, Constanta, and Varna reported record shipping traffic. The number of commercial vessels calling at major Black Sea ports climbed into the thousands each year by the early 1980s. Bulk carriers, tankers, and container ships arrived from the Americas, West Africa, and Asia, often empty and heavy with ballast water. Each arrival meant the discharge of tens of thousands of tons of untreated ballast, ocean water teeming with invisible hitchhikers. In a single year, the aggregate ballast released across the region reached into the tens of millions of tons. No protocols existed to treat or even monitor what came out of the holds. For port inspectors, the focus was on cargo manifests and customs fees, not on the microscopic life swirling in the runoff from a ship's hull. Environmental monitors tracked the mounting signs of stress. Oxygen-poor dead zones expanded near the mouths of the Danube and Dniester. Fish kills became more frequent after heavy rains. The sea's natural defenses, its ability to absorb waste, recycle nutrients, and support a web of predators, were quietly eroding. All the while, the shipping lanes grew busier, and the water column grew richer in nutrients and foreign plankton. The Black Sea was becoming a crossroads, not just for trade, but for biological risk. Beneath the surface, the stage was set for an invader to slip through the cracks, carried in the dark belly of a freighter, ready to thrive in a sea already pushed to its limits. In November 1982, a research vessel docked near Odessa collected a plankton sample that would go mostly unnoticed. Among the copepods and native jellyfish, a handful of unfamiliar translucent comb jellies drifted in the net. Mnemoniopsis lidii, a species native to the Atlantic coast of North America. The find was recorded in a logbook and identified only after preserved specimens reached a Moscow laboratory months later. No alarm was raised. In the years that followed, marine biologists conducting routine surveys along the northwestern Black Sea coast noted occasional appearances of the same sea ctenophore, but always in low numbers, 1 or 2 per cubic meter, sometimes none at all. Transect records from Constanta and Sevastopol told the same story. Isolated dots on abundance maps, never a continuous spread. Port authorities and customs officers remained focused on cargo, not on the microscopic life swirling in ballast tanks. Ships arriving from the Americas discharged tens of thousands of tons of untreated ballast water with every visit. Ballast logs and shipping manifests from 1982 to 1986 show no mention of biological inspection. The comb jelly, invisible to the naked eye and harmless in appearance, slipped through the cracks again and again. On board the research cruises, the presence of Mnemoniopsis was dismissed as an oddity. Soviet, Romanian, and Bulgarian scientists sorting plankton hulls in the early 1980s were trained to look for fish larvae, not gelatinous newcomers. The nets they used, standard WP2 and Jude models, were designed for zooplankton, not for catching fragile ctenophores. Many early specimens likely disintegrated before reaching the sorting trays. Still, by 1986, a pattern began to emerge. Coastal surveys near the Danube and Dniester deltas started to report low but persistent numbers, always highest near the approaches to busy ports and river mouths. No one could yet see the threat. The anchovy fishery continued to fill docks from Batumi to Varna. To the scientific community, the new arrival was a curiosity, not a warning. Only a few biologists flipping through field notes and comparing samples from year to year wondered how a species from the distant Atlantic could appear so quietly in the Black Sea. Their questions went unanswered. The invader had established a foothold, hidden in the shadows of a stressed ecosystem, waiting for its chance to multiply. By the summer of 1988, the Black Sea's surface was thick with comb jellies. Plankton surveys recorded densities up to 400 individuals per cubic meter, enough to fill a bucket with gelatinous bodies in a single haul. Where once fishermen hauled up nets heavy with anchovy, they now dragged in masses of translucent flesh, slippery and useless. The transformation was so sudden that catch logs from Sinop, Constanta, and Varna show a collapse in real time. Anchovy landings fell from 750,000 tons in 1988 to barely 20,000 tons by 1991. In just 3 years, the backbone of coastal economies snapped. Fishermen who had worked the water for decades returned with empty hands. In Sinop, one captain wrote in his diary, "We emptied the nets, nothing but jellies, again and again. My father cried in the wheelhouse. I thought we would never see anchovy again." The shock spread from dock to market as buyers and fishmongers faced stalls lined only with glistening, inedible comb jellies. 20 of 26 commercial fish species vanished from the records. The dolphins, once ever present around the fleets, dwindled by 80% as their prey disappeared. The economic toll was immediate and severe. In 1992 alone, the fishing industry lost more than $330 million. Smokehouses went cold. Shipyards fell silent. Generations of fishing knowledge passed down in Turkish, Bulgarian, and Romanian families suddenly held no answers for a sea that had turned against them. Oral histories from Constanta recall the disbelief. We tried different nets, different depths, but every time it was the same. The sea was full, but not with fish. Scientists, too, scrambled for explanations. Survey ships logged the bloom's advance with mounting alarm. Reports described the Black Sea as a gelatinous wasteland, with comb jellies crowding out every other creature in the water column. The scale was staggering: 900 million tons of biomass, 10 times the world's annual fish harvest, concentrated in a single enclosed sea. The collapse was not gradual, it was a free fall. And for the communities around the Black Sea, it felt as if the water itself had been emptied of life. Emergency meetings convened in Istanbul and Varna throughout 1990, bringing fisheries managers from all 6 Black Sea nations to the table. Delegates pored over catch statistics and satellite images of the jellyfish bloom, searching for solutions as the anchovy fishery collapsed. Proposals for strict catch limits and seasonal closures dominated the agenda. Turkish and Soviet representatives, facing the steepest losses, pushed for immediate, sweeping restrictions. Romanian and Bulgarian officials argued for leniency, citing the risk of mass unemployment if their fleets were grounded. The resulting agreements imposed new quotas and shortened fishing seasons, but the measures arrived late. By mid-1990, scientific surveys showed almost no juvenile anchovy in the water. Recruitment had failed, and the fisheries foundation was gone. On paper, the new rules looked decisive. In practice, they were riddled with loopholes. Enforcement varied widely from port to port. Some captains ignored quotas altogether, desperate to salvage what little income remained. Spotty inspections and a lack of cross-border coordination meant that illegal landings continued, especially at smaller harbors far from central oversight. Diplomatic cables and summit minutes reveal mounting frustration among regional managers, who found themselves powerless to stop the hemorrhaging of both fish and livelihoods. The sense of crisis deepened as nets came up empty, no matter how many rules were written. Attention turned to more direct interventions. Some scientists floated the idea of harvesting the comb jellies themselves, hoping to turn the invader into a resource. Pilot projects deployed modified trawl nets and suction pumps, but the results were dismal. Menemyopsis ladii is 98% water. Hauling tons of gelatinous bodies yielded almost nothing of commercial value. The delicate ctenophores slipped through mesh or disintegrated on contact. Processing plants refused deliveries, unable to find any market for the watery pulp. Reports from Ukrainian and Turkish gear trials documented the futility. Thousands of labor hours spent for a handful of barrels, all destined for landfill. Meanwhile, environmental ministries tracked a brief dip in nutrient pollution after the Soviet Union's economic collapse. Fertilizer shipments and factory discharges dropped sharply between 1991 and 1994, leading to lower phytoplankton blooms. Some officials hoped that with less food in the water, the jellyfish population would crash. Yet Menemyopsis endured, exploiting every remaining patch of productivity. Survey logs from 1992 confirm that, even as nutrient levels fell, comb jellies remained the dominant life form in the sea. With no native predator capable of controlling the outbreak and conventional policies failing at every turn, managers faced a bitter reality. The Black Sea had become a case study in the limits of human intervention. Emergency quotas, gear innovation, and environmental reprieves all proved powerless against a biological invasion on this scale. The region waited, trapped between economic desperation and ecological paralysis, for any sign that nature might take a different course. In the late 1990s, marine biologists surveying the Black Sea began to notice a new, unfamiliar comb jelly drifting among the remnants of the Menemyopsis swarm. Barrow ovida, native to the Atlantic, had arrived, likely carried in the ballast water of a commercial ship, just as Menemyopsis had been years before. Its appearance was first documented in 1997, with initial densities so low that some researchers dismissed the find as a statistical blip. But Barrow ovida brought with it a singular appetite. It fed almost exclusively on other comb jellies, and in the Black Sea, that meant Menemyopsis ladii. Field studies and laboratory feeding trials quickly confirmed Barrow's specialization. Gut content analyses revealed Menemyopsis fragments in more than 95% of specimens, while controlled experiments showed Barrow ignoring zooplankton, fish eggs, and larvae, even when starved. The predator's arrival was a biological coincidence, not the result of any deliberate intervention or management plan. Yet, for the first time since the collapse, there was evidence that the runaway invader might not be untouchable after all. By 1999, barrow populations had begun to expand, tracking the highest concentrations of Nemiopsis across coastal and open waters. Surveys recorded local densities climbing to 10 or 15 individuals per cubic meter in areas where Nemiopsis was still abundant. The relationship was direct and visible. Wherever barrow numbers surged, Nemiopsis biomass fell sharply. Within 2 years, the gelatinous tides that had overwhelmed the Black Sea were in rapid retreat. Nemiopsis densities dropped by as much as 90% in some regions, with annual blooms shrinking to a fraction of their former scale. Scientists documented the transformation with a mix of relief and unease. The food web, once locked in a cycle of collapse, now showed signs of rebalancing. Anchovy egg and larval survival rates improved, and the first signs of fishery recovery appeared in Turkish catch statistics. Yet the solution carried its own ethical and ecological weight. Baroi ovata, though effective, was itself an introduced species, a permanent addition to the Black Sea's altered ecosystem. Researchers debated whether this accidental control represented a true restoration or simply the stabilization of a new regime, one in which invasive species policed each other, and the original diversity of the sea remained out of reach. The arrival of Baroi ovata was not a triumph of policy or planning, but a twist of biological fate. Its impact was undeniable. The unchecked dominance of Nemiopsis lydii was broken by a predator even more specialized than any native to the region. For the fishing communities and scientists who had watched the sea unravel, Baroi's presence offered hope, but also a reminder that in the Black Sea, nature's solutions often come with their own set of questions. Today, the Black Sea's fish stocks remain half of what they once were, and invasive species still shape its future. As global shipping, warming waters, and pollution accelerate, no coastline is immune. The lesson endures. When ecosystems unravel, recovery is never guaranteed. The next tipping point may not wait another 35 years.